There is an image in astronomy that looks almost too simple to change history. A black background, a hidden star, and a few tiny points of light. That's it. No oceans, no cities, no alien landscapes, no glowing continents beneath strange skies. Just dots. But those dots are not stars. They are planets, real worlds orbiting another sun in a solar system far beyond our own. For thousands of years, humanity looked up at the night sky and wondered if our solar system was unique. Were we alone in having planets? Was the sun special? Were Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune part of a rare cosmic arrangement? For most of history, the answer was hidden. We could see stars, but not the worlds around them. Then humanity did something that once sounded impossible. We didn't just guess another multi-planet system existed. We didn't just measure a star's wobble. We didn't just detect a shadow passing across distant starlight. We saw it. Actual light from planets outside our solar system traveled across space, entered our telescopes, and became an image. A real image of multiple planets orbiting another star. And in that moment, the universe became larger than ever before. Because the question was no longer, do other solar systems exist? The question became, how many are out there? This is the story of the first image of another multi-planet solar system. And it begins with one of the hardest challenges in astronomy. Trying to photograph an exoplanet is like trying to see a firefly next to a lighthouse from thousands of miles away. The star is blinding. The planet is faint. The star floods everything around it with light, hiding the planets in its glare. Even a giant planet, many times larger than Jupiter, can disappear beside its parent star. That is why, for decades, astronomers found planets without actually seeing them. They watched stars wobble from the gravity of unseen worlds. They watched tiny dips in starlight when planets passed in front of their stars. They measured shadows, movements, and invisible gravitational clues. It was brilliant science, but it was not a photograph. It was like knowing someone was standing in a dark room because you could hear their footsteps. Direct imaging is different. Direct imaging means capturing the planet's own light. Not a shadow, not a wobble, not a clue. Light from the world itself. And that is what made the first direct image of a multi-planet system so extraordinary. The system was called HR 8799. It lies about 130 light-years away from Earth, in the constellation Pegasus. That means the light from this system began traveling toward us more than a century ago. HR 8799 is not a perfect copy of our solar system. It is younger, brighter, and more extreme. Around it orbit giant planets, each far larger than Earth, each moving through the darkness around its star. In 2008, astronomers announced that they had directly imaged multiple planets orbiting HR 8799. Not one planet, multiple planets, in the same system, seen directly. Imagine that moment. Scientists staring at the data, knowing that if the dots were real, they were looking at something humanity had never truly seen before. But they had to be careful. A dot near a star could be many things. It could be a distant background star. It could be noise. It could be an optical artifact. It could be a false signal created by the telescope, the atmosphere, or the data itself. So astronomers did what science always demands. They checked. They waited. They compared images taken at different times. If the dots were background stars, HR 8799 would move past them. But if the dots moved with the star, if they stayed gravitationally connected, if they slowly shifted in their orbits, then they were something far more incredible. They were planets. And that is exactly what the evidence showed. Those faint dots were not random lights. They were worlds. Worlds orbiting another sun. For the first time, humanity had a family portrait of another multi-planet system. The image itself was quiet, but what it represented was enormous. Each dot was a planet. Each planet had its own atmosphere, its own temperature, its own chemistry, its own history. These were not Earth-like worlds. They were giant planets, massive and young, still glowing with heat from their formation. That glow helped make them visible. Young giant planets are easier to image because they still radiate infrared light. They are like embers left behind after the fire of planet formation. The universe created them, and while they were still warm, humanity managed to see them. But seeing them required extraordinary technology. Earth's atmosphere is always moving. Air bends and distorts light. That is why stars twinkle. To the human eye, twinkling is beautiful. To an astronomer trying to image a planet, it is a problem. So telescopes use adaptive optics. This technology corrects atmospheric distortion in real time, sharpening the image by adjusting mirrors many times per second. Then, astronomers use special techniques to block or remove the overwhelming light of the star. Because to see the planets, they must first silence the sun. In many direct images, the central star is hidden or digitally removed. That dark space in the middle is not empty. It is where the star's blinding light has been suppressed so the planets can appear. And that is what makes the image so haunting. The star is there, but hidden. The planets are faint, but real. It is as if the universe whispered, "Look closer." HR 8799 changed astronomy because it proved that direct imaging could reveal entire planetary systems, not just single planets, systems, structures, cosmic architecture, another arrangement of worlds built by gravity, dust, gas, and time. Then, years later, another image captured the world's attention. This time, the star was TYC 8998760-1. This system became famous because it showed multiple planets orbiting a sun-like star. That detail mattered, because when we hear sun-like, something changes in our imagination. Suddenly, we are not just thinking about any distant star. We are thinking about something that echoes home. TYC 8998760-1 is about 300 light-years away. It is much younger than our Sun, only about 17 million years old. Compared to our 4.6 billion-year-old Sun, this star system is a newborn. Its planets are huge, much larger than Jupiter, and they orbit far from their star. They are not habitable worlds. They are not places with oceans or forests. But they are proof of something profound. Nature builds planetary systems in many different ways. Some are compact, some are wide, some have giant planets far from their stars, some have rocky worlds close in, some may resemble our solar system, most probably do not. The universe is not copying one design, it is experimenting. Every star may be a different version of what gravity can create, a different outcome of dust and time, a different answer to the question, what can a solar system become? When we look at these images, we are seeing the early chapters of planetary history. A star forms inside a collapsing cloud of gas and dust. Around it, leftover material flattens into a spinning disk. Inside that disk, tiny particles collide. Dust becomes pebbles, pebbles become rocks, rocks become larger bodies, and eventually, some of them become planets. If a planetary core grows large enough fast enough, it can pull in gas and become a giant world like Jupiter. This may be how the giant planets in our own solar system formed. So when astronomers study systems like HR 8799, they are not only studying distant planets, they are studying the story of how solar systems are born. They are searching for clues about our own past. Why did Jupiter form where it did? Why did Earth become stable? Why did our solar system survive in a way that allowed life to appear on one small rocky planet? Every distant system is a mirror, Not a perfect mirror, but a mirror showing what might have happened. What if Jupiter had moved inward? What if Saturn had formed differently? What if Earth had been thrown into the cold darkness? What if our solar system is not typical at all? The first image of another multi-planet system forces us to confront a humbling truth. Our solar system is not the whole story. It is one chapter in a much larger cosmic book. And now, for the first time, we can see other chapters. The image of HR 8799 does not look like science fiction. It does not show clouds, rings, moons, oceans, or storms. It shows faint dots. But those dots are enough. They prove that planets can be photographed across impossible distances. They prove that other solar systems are not just theories. They prove that the universe is filled with hidden worlds waiting for our technology to catch up with our curiosity. And this is only the beginning. Future telescopes will go further. They will block starlight more precisely. They will separate planets from glare more clearly. They will study atmospheres in more detail. They may find water vapor, methane, carbon dioxide, and other chemical fingerprints. One day, they may capture a direct image of a small rocky planet. Not a giant, not a young world glowing with heat, but a planet closer to Earth. A pale point of light orbiting in the habitable zone. A world where liquid water might exist. A world with an atmosphere. A world that makes scientists stop and ask the biggest question of all. Could something be alive there? That is the dream behind these first images. The first direct images of multi-planet systems are not the final destination. They are the beginning of a new age. The first image is always blurry. The first image is always limited. The first image is always only the first step. But first images change civilization. The first photographs of Earth from space changed how we saw our planet. The first images of galaxies changed how we saw the universe. The first image of a black hole changed how we saw gravity itself. And the first image of another multi-planet system changed how we saw our place among the stars. Because suddenly, planets were not invisible anymore. They were not just numbers in a chart. They were not just signals in data. They were points of light, real worlds, orbiting real stars. Somewhere in the darkness, another solar system was moving through time, and we saw it. Think about what that means. The light from those planets crossed more than 100 light years of space. It traveled through darkness for generations. It passed between stars. It moved silently through the galaxy. Then it reached Earth. It entered a telescope. It became data. Then an image. Then proof. Proof that our solar system is not alone. Proof that worlds exist beyond the reach of human eyes. Proof that the universe has been building planets everywhere long before we had the ability to see them. And maybe, hidden among the billions of stars in our galaxy, there are other systems waiting. Some with giant planets. Some with frozen worlds. Some with planets scorched by their stars. Some with moons larger than Mercury. Some with storms that could swallow Earth. And perhaps somewhere, a small rocky planet with oceans beneath a blue sky. We do not know yet, but every new image brings us closer. Every better telescope pulls another secret out of the darkness. Every faint dot teaches us that the universe is more crowded, more complex, and more beautiful than we imagined. The first image of another multi-planet solar system was not just a scientific milestone. It was a message written in light. It said there are other worlds. It said the sun is not alone.
It said the story of planets is happening across the galaxy.
And one day, when humanity finally sees a true Earth-like world around another star, we may look back at those first faint dots and realize something incredible. That was the moment our vision crossed a boundary. That was the moment the universe stopped being only stars and became worlds.
Thank you for watching Infinite Science. The next great discovery may already be traveling toward us as light. Somewhere out there, another solar system is waiting to be seen. And every time we build a better telescope, the universe reveals a little more of itself. Until next time, keep looking up.